Yeah, so the next part is let's do equations, and algebra spans across everything, right? So let's do equations. So what are equations? Well, it's when both parts, so the left hand side and the right hand side, are equal to each other. So you have an equal sign in between, and you could have linear equations where it's just x term, so x to the power of 1 being the largest x term, or you can have quadratics, which is x squared, and then you can have, so you can have like x squared plus x plus 1 or whatever it might be, but you've basically got the x squared term as the highest power of x, so x to the power of 2, which follows on from what we've been talking about in terms of powers. So how do we calculate these? Well, first of all, we could have something very simple like y equals 3x plus 1. Now we know that this is in the form y equals mx plus c. And I hope you know by now that m refers to the gradient and the c refers to the y-intercept. Now these might seem like big and daunting terms, but really the gradient just means what is the slope looking like. So is it going upwards? Is it going downwards? And how steep is it? So the analogy that I give to my students really is, imagine you're going on a trek and you're climbing up a mountain. When you're going up the mountain, it's uphill. So that is a positive gradient. You're going up in height. And then when you're coming down, it's a negative gradient. So you're coming down in height, in the altitude, strictly speaking. And then if you have a very steep climb, then that is a higher gradient. The greater the value of m, the steeper the gradient, basically. And same rule follows for when you're coming down the mountain. So that's the gradient. And the y-intercept is simply on a graph where there's a straight line across the y-axis. So whatever this point is, that is the y-intercept. So now, how do you calculate this, by the way? So imagine you had a question which might be something like, um, the line, no, it could be something like a line. Yeah, a line passes through a coordinate 2 and 4, and then another coordinate 8 and, okay, let's make the numbers not too difficult. So that might be 16. So work out, we have to work out in the form y equals mx plus c. So the first thing we do is work out the gradient. So we do m equals the difference in the y values. So this is y here, this is y here. So we do 16 take away 4 divided by the difference in x values. So 8 and 2. So 8 minus 2. So 16 minus 4 is 12. 8 minus 2 is 6. So the gradient is 2. So for every 1 that we move across on the x-axis, we move up by 2 on the y-axis, right? So that's the gradient. Now we have to work out the y-intercept. How do we do that? Well, there's a couple of different ways. So we know, first of all, that we can use this equation, y minus y1 equals m brackets x minus x1. And here, by the way, we can never substitute anything for the y and for the x. They stay as y and x. But for y1 and for x1, we basically can pick either the x1, so the x coordinate, which is 2, and the y coordinate 4, or we can pick the 8 and the 16. It doesn't matter. We just have to make sure that if you're using the 2, you use the 4, and if you're using the 8, you use the 16. We just have to be consistent in that manner. So let's go with 2 and the 4 because they're smaller numbers. So we can do y minus 4 equals, and remember our m is 2, so we do 2 brackets x minus 2 because we're substituting the x1 for the 2 as we spoke about earlier. And then you simply just expand it out. So y minus 4 equals 2 times x is 2x, 2 times minus 2 is minus 4. And then we want to get the minus 4 on this side, so we get the y by itself. So when you take the negative 4 here, it becomes a positive 4. So we get 2x minus 4 plus 4, which is just 0. So y equals 2x. So that we know is, because it's plus 0, we know that the y-intercept will be 0. So then we can just sketch it nicely on a graph. And I'm not going to label the axes right now, but it looks something like this. The gradient is steeper than 45 degrees because it's not a y equals x line, which is 45 degrees, it's more than that. So that's how we can do it through algebra. However, there's more methods as well. So we can quickly run through it using so if you didn't know the coordinates, for example, so imagine you had to sketch the line visually, but you were only given a line. So let's move on to a different question actually. So let's say y equals 3x plus 1. I think I spoke about it earlier. So did I? Yes, I gave as example earlier, didn't I? So y equals 3x plus 1, and then we actually have to plot it on a graph. So I hope that many of you have already done this table method, so x and y. So you start from, I typically with my students start from -3, -2, -1, 0, 1, 2, 3. And then you say, okay, if x is -3 here, then what does y equal? So then you have 3 times -3 is -9, plus 1 is -8. 3 times -2 is -6, plus 1 is -5. 3 times -1 is -3, plus 1 is -2. And then 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6, plus 1 is 7. And 3 times 3 is 9, plus 1 is 10. Now, what I'm sure you all know by now is, let's look at the difference. They always go up in threes. And the reason being is because the gradient is 3. So what the gradient by definition is, if you go up by 1 on the x-axis, then the y-axis goes up by the gradient. And here we're going up in 1, so we're going from -3 to -2, -2 to -1, and so on. And each time the y value goes up by 3. Now you'd get these coordinates and you'd be able to plot it on a graph. Great, easy. However, it's paper 3, you have a calculator available. Okay, so this calculator has a table function, so we click on that, and then we want to define what our f of x, g of x. Now all of this sounds a bit confusing, so you probably might have come across this already, and then you've decided not to go ahead with it. So f of x just means the function of x. Now here, the function is y equals 3x plus 1. So f of x, the function of x, is literally what y is, which here is 3x plus 1. So we are only dealing with 3x plus 1, so we can ignore the g of x, which is like if you're dealing with two functions. So we can go here and we can actually define what f of x and g of x are. So let's define f of x, put it into the equation. So it's 3, and then it's x that we are using. So where do we see x on the calculator? Well, it's here, the letter. So if you click on shift and then you look at this here, we've got x. So 3x, and then we want plus 1. So we've defined our function. Then we look at g of x is none, which is fine. And then if you go back to the tools, table range. So we want to start it at -3. And we want to end it at 3. And the step is how much we're going up in. And as I said earlier, we're going up in ones. So that is fine. 1, yep. And then execute. And the g of x will come up as an error because we have not defined it. So we don't need to worry about that. But it's showing us very quickly, x is -3, f of x, which is our y, is -8. And then x is -2, y is -5. And that's exactly what we have here. So you can use your calculator to double check your answer in the exam if you get the time. And if you want to be quicker in the exam, then you've got a very powerful tool right here. So let's move on to quadratics now, because linear is quite straightforward anyway. So if you have a quadratic, and let's say it's something like, okay, so y equals x squared minus 5x plus 6. Now there are 4 different ways in which you can solve a quadratic. So the first one is factorization, which I hope all of you are experts on by now. The second one is the quadratic formula, which I can flash up on the screen. I can write out, but it's minus b plus or minus square root of b squared minus 4ac, and then all of that divided by 2a, and it's really important that you've got, so it's in the form y equals ax squared plus bx plus c. So in this example, so we've got y equals x squared. So there's no number, no constant ahead of the x squared. So it's just 1. So there's one lot of x squared. So our a is 1. Our b, like how many lots of x do we have? Well, it's minus 5 lots of x. So b is minus 5. And our c is the number by itself, no x term, which is 6. So that you can plug in to the quadratic formula. I'll also show factorization. So there are 4 methods, like I said. So there's factorization, there's quadratic formula, there's also completing the square, which is for higher tier only, and then there's also the graphical method. So to be able to do that, you can again use the table like the one that I showed earlier. So start x from, let's say, minus 3 to positive 3, or whatever you want to do in terms of a sensible range, but try around the origin to begin with, around 0. And then you can get the y values and then plot it on the graph. And then here, the x value will basically show you where it's crossing the x-axis. So this point here and this point here, they are your 2 solutions for x. So you'll always get 2 solutions typically with quadratics. Not always, but typically. And there are special cases where you only get 1 solution. But let's keep it simple for now. So let's look at factorization. So we get 2 brackets, and this one's nice and easy. So we have to get x squared here. So it has to be x multiplied by x. And then you have to find 2 numbers which multiply to get a positive 6, but they add to get negative 5. Well, we know already that 6 has how many factors? So it's got 1 and 6, and then minus 1 and minus 6. And then you've got 2 and 3. And you've got negative 2 and negative 3. So those are the factors. Then you want to see which 2, when you add them up, they give you negative 5. Well, when you add 1 plus 6, you get 7. So that can't be it. When you do minus 1 plus minus 6, you get minus 7. So that can't be it. When you do 2 plus 3, you get 5, like positive 5. So that can't be it. When you do negative 2 plus negative 3, you get negative 5. So that is the one. So we do minus 2 here, minus 3 here. And therefore, our answers are x equals positive 2 and x equals positive 3. The reason being is we always equate this, like we put it equals to 0. So if x minus 2 was to equal 0, then x equals positive 2. And if x minus 3 was equal to 0, x would equal positive 3. But there's a quicker way to do it on the calculator, and this is paper 3. So let's go through that again. So what we've got is, press home again, and we've got a equation function. So let's click on that, and then let's click on polynomial. So polynomial just refers to any of these quadratics, cubics, quartics, but you don't have to worry about quartics at GCSE. So let's look at quadratic, and then ax squared plus bx plus c. So this effectively uses the quadratic formula. And then what is your a? Well, we said earlier that our a in this example is 1, right? So it's a is 1, b was minus 5, and c was 6. So we plug that into the calculator, and we are given x1, so the first value of x being 3, and the second value of x being 2, which is what we had earlier.